The value of Bob's car can be calculated from this formula here, where V is the value of the car in pounds and T is the age in years. Find the value of the car when T is 0. Calculate the exact value of T when V is £9,500. Find the rate at which the value of the car is decreasing at the instant when T is equal to 8. Give your answer in pounds per year to the nearest pound. Okay, let's have a look at this one then. Put in T as 0 then for part A. V is equal to T to the 0, E to the 0 is 1, so it's 17,000 times 1. E to the 0, so plus another 2,000 then, plus the 500. So that's equal to £19,500 to start with. Calculate T when V equals £9,500 is equal to 17,000 e to the minus 0.25t plus 2,000 e to the minus 0.5t's rather, plus the 500. So if we cross that off with that one, and this will leave thousands, and then if we cross the thousands off all the way through, we can see that we've got, and then multiply by e to the 0.5t, I think. Yeah, I'd like to do that really. Gives, so we've got 9 e to the 0.5t is equal to 17 times by this, you just add the powers, so that would be e to the 0.5t plus 2, and then this would be e to the 0, which is 1, so 2 times 1 is 2. So this is just a quadratic, isn't it? So 9 e to the 0.25t, we can write 0.5t as 0.25t squared, move the 17 over, and move the 2 over equals 0. 9 2s are 18. So hopefully it's 9 and 1 and 2 and 1, isn't it? Here and here. That's a minus, this is a minus, so presumably this would be a minus, this would be a plus. Let's just check that then. 9 e to the 0.25t squared minus 18 plus 1, lots of this, is minus 17. Plus times a minus is a minus, 2 ones are 2. So that's great. So this tells us that e to the 0.25t equals minus 1/9, or e to the 0.25t equals a half, isn't it? 2 rather, sorry. 2 in here. This one will give no solutions. So, because it's a negative and it's an exponential, it's never negative. So this one, take logs. So when we write this in log form, the e shrinks down to be the base, so it's natural log of 2. And that tells us this is a quarter, so t will equal 4 ln 2. Just move the quarter, the 4 underneath, up to here. T is 4 log 2 years. So that's what we get there for the time in this part. Let's look back at the question then. Calculate t when v is 9,500, which we've done. I think it might have said exactly. Let's go back to the question just to check. Exact value, yeah, that's fine. So, part C, find the rate at which the value is decreasing when t equals 8. So we need dv dt, don't we? So part C, dv dt is equal to, Okay, here's the actual function then. So it's 17,000 e to the something t. So it's a function of a function rule. This quarter comes down. So 17 e to the something differentiates to e to the something, multiplied by the something differentiated, which is minus 1/4, because the 0.25 with the minus is minus 1/4, plus 2,000 lots of e to the something differentiates to e to the something, minus 0.5t, multiplied by the minus 1/2 here, something differentiated, and then the constant here goes to 0. So dv dt is equal to that then, which equals, divide by 4, 8,500, 4,250, minus 4,250 e to the minus t over 4, plus, that's a quarter, rather than write the decimal, minus 2,000 over 2 is 1,000, e to the minus 0.5t is minus t over 2, which equals, now when t equals 8, wasn't it? Yeah, 8 minus 4,250 e to the minus 8 over 4 is 2, minus 1,000, 8 over 2 is 4, is e to the minus 4, which equals, let's type it in the calculator then. So it's negative 4,250 times by e to the negative 2, ground level, minus 1,000, times by e to the minus 4, negative 4, equals minus 593.49. 4949 minus 593.49. And that would be the rate of increase of the thing, and it asks for the rate at which the value is decreasing in pounds per year. So rate of decrease equals 593.49 to the nearest pound. So that would be 593 pounds per year to nearest pound, wasn't it?